Hi everyone, thanks for joining. We're gonna wait for a couple more minutes to have some more people joining, and then we'll jump right in. Feel free to say hi in our chat in the meantime until we start.
Yeah.
I'm going to wait for one more minute because I'm seeing we're still getting more participants in, and then we'll kick off.
Yeah, we should start when we have 100. That's a good number.
Cool. So I think we can kick it off. So thanks everyone for joining us for a replay of our design pattern for Salesforce CI/CD session that was originally presented on the last Dreamforce event that took place not too long ago. For those of you who missed it, we decided to run this session again due to the high demand. The queue to get inside the room was so long, and not everyone were able to make it in. I almost didn't make it myself. I was also there queuing, and I made it into the final cut. So we thought it was a good opportunity to repeat the content and give more people opportunity to see it live. Our team for today, my name is Sagi, I'm from Salto's marketing team, and our main speaker for the event is going to be Pablo, which I hope most of you know already. Before we jump into Pablo's presentation, I just wanted to give a quick intro to Salto, to those of you who may not know us. So Salto is on a mission to help business applications professionals to deliver high quality configuration changes faster. We do it by translating metadata and configuration data into one standardized language, which allows our users to understand what's implemented in their business applications and understand dependencies, compare environments or orgs and deploy changes between them, edit metadata files and run complex operations like bulk metadata changes, and also integrate with version control or CI/CD providers to help automate some of your release management processes. And that's kind of our bigger vision. If you want to give it a try, we have a forever free plan which you can come check out. You can check it. You can either scan this QR code or to use this link. What you'll be able to do there, you'll be able to search your organization and find anything in your metadata or hard-coded values. And you can also detect dependencies, get alerts on changes in your org, etc. So feel free to give it a try. And I promise you, you won't be disappointed with our metadata visualization. It's really nice and nothing that you had a chance to see so far. So come check it out. Before we continue, a few quick housekeeping stuff. The session will be recorded, and we will be sharing the link following the event. And feel free, we really encourage you to share any questions you may have throughout the event. At the bottom of the call, there should be a Q&A widget that you can use, and feel free to post your questions there, and Pablo will do his best to address those during the session. And I think we're ready to go. Pablo, you're going to take over?
Yeah. So let me share my screen. And yes, feel free to use the chat to just say hi or throw any questions, and I'll try to answer them as we go. And if you see some question that I haven't answered and you know the answer, feel free to answer it. I don't want this to be a death by Zoom. I want it to be interactive as much as possible. So feel free to do that. Okay, so let me share my screen here. Can you see my screen now with the slide?
Yep. Good.
Okay, so the agenda for today, right? This was a session that I did at Dreamforce. So it's pretty much the same content. We're going to start with a little bit of mandatory history on CI/CD. Then we're going to see what are the patterns for creating a Salesforce deployment pipeline. We're going to do this using GitHub Actions. Then we're going to see a full demo, and there's going to be a lot of code. So don't worry, there's going to be a lot of theory, but at the end, there's going to be a good amount of code. And then at the very end, we're going to talk about what the design patterns are. And obviously, this is at the end so that you stay until the end. Okay, so first of all, we like to do just a quick poll just to understand where people are in their journey for learning CI/CD. So Sagi, can you help me please pulling up the poll?
Yep. Cool. So the first questions, where are you in your Salesforce CI/CD journey? I see answers are already populating. So I guess everyone got it. Let's wait another minute.
I didn't expect we would see the answers being coming in real time. That's very nice.
Yeah, cool. And almost everyone answered. Let's give the last few people one more. Yeah, okay. I think we're good enough. 90% response rate. Yeah, so the answers are quite diverse, I'd say.
Can we share them?
Yeah. Can everyone see the results?
Yeah.
So they're quite diverse. I see people are in different stages of their CI/CD journey. So that's interesting to see.
Yeah. And I want to talk to those 8 who said that they could be delivering this session. We'll talk about that later. Okay, cool. So let's jump right in. So first of all, let's talk about continuous integration. To understand continuous integration, we first need to understand what are the challenges that it tries to solve. So as you know, combining the work of multiple developers is hard. And in traditional software development, we use branches to isolate work. And in the case of Salesforce, we use branches and sandboxes as well, so that everyone can have their own isolated environment. The problem with this is that branches and sandboxes can diverge a lot from each other. The longer that they exist, the harder it is to eventually merge them together. And this can lead to very complicated merges and very complicated release activities, which in the end means that your release process will be very expensive and simply unpredictable. So because of these problems, the need came for continuous integration, which is really a software development practice where members of a development team integrate their changes as frequently as possible, sometimes even multiple times a day, into a common branch of a version control repository. So the idea is that every time you commit a change, there's an automated process that builds the application and it runs unit tests. And it's supposed to give you a very simple pass or fail. Did you break the application, or does your change work or play along with everything else that is being developed by other developers? Now, continuous integration is actually very hard to do in practice, because for this to work, tasks need to be broken down into smaller chunks. So for us to be able to commit frequently, we actually need to commit or even deploy changes that are not finished. And this is actually very strange to think about, because I think in the Salesforce world, we always deploy something once it's fully done, right? Once we have all the page layouts, all the fields, all the Apex classes, only then we are confident deploying that or maybe committing that. But in the continuous integration world, we're actually encouraged to deploy those things or even commit them, even if they're not finished. And then obviously this raises a lot of questions about, well, how can I deploy or commit something that is actually not finished? And there are some techniques to get around that, such as feature flags or feature toggles, also branch by abstraction. Those are topics that I'm not going to cover, but just trying to make sure that we understand that continuous integration is actually a paradigm shift on how we develop, and it's not easy. It doesn't come natural to us. The second problem or challenge with continuous integration is that, as I said, the idea is that you run tests and very quickly you get feedback. Did you break the application or not? And in the case of Salesforce, unfortunately, the tests run asynchronously. Sometimes they can take a very long time to run in a large org. Sometimes it's actually really hard to test certain features because you may hit governor limits just while you're preparing the data. And I think also as an ecosystem, we lack consistency in the way that we test Apex. So again, this is not to say that it's not possible to do continuous integration, but I just want to be very clear that it's more than just having some automation that deploys to the next environment. Now, continuous delivery, to explain this, I'm going to actually quote Jess Humble from the book Continuous Delivery, where he says that continuous delivery is the ability to get changes of all types into production safely and quickly in a sustainable way. So continuous delivery is not something that you do, it's not a product that you buy, it's not a project that you do and then you finish. It's really a set of principles for software delivery. So let's go over some of these principles. The first one is to build quality in, which basically just means you should fix bugs as soon as they're found and as close to their source as possible. The second principle is, again, working in small batches. And this is because we want to shorten the feedback loop, right? We want to get that feedback as soon as possible, which is, again, what's going to enable us to do continuous integration, which is one of the practices of continuous delivery. Another principle is to automate everything that can be automated and let humans focus on higher value add activities. And finally, as I said, CI/CD or continuous delivery is not a goal. It's not a project that you implement and then you're done. It's something that you need to keep working on. It's something that you need to keep improving. So with that said, one of the concepts that emerged from the continuous delivery movement is the concept of a deployment pipeline. And this concept doesn't really translate too well to the way we develop in Salesforce. It's a little bit different because we develop on a cloud software. So I sort of modified it a bit to come up with the concept of a Salesforce deployment pipeline, which I'm going to define as an automated process that runs your Salesforce metadata through a series of steps, such as quality checks, unit tests, and deployments. And this process fires in response to events in your version control repository. The idea is that as your metadata goes through these steps successfully, we get more confidence in the quality of this implementation, which in the end results in us having something that we can or we feel confident can be deployed to production. So then in this webinar, we're going to see what are the principles for creating a Salesforce deployment pipeline. And as we go through the principles at the end, we'll see that some patterns emerge. Okay, so one thing that I want to be clear on is that these are patterns, they are not mandates. So I won't be telling you what to do or what not to do, because that's impossible. Every Salesforce org is different, everyone works different, every team is different. So instead, what I'll be doing is I'll be telling you what I think you should be thinking about. What are the questions that you should be asking yourselves? But in the end, it's up to you how you answer those questions. And I am of the opinion that you should do whatever works for you. Okay, so the first principle is all about having a sandbox strategy. So we're going to do another quick poll. This is the last one, I promise, just to understand what people are doing with their sandboxes today. So Sagi, if you could help me with that, please.
Yeah. So which of these most resemble your sandbox strategy? This is the current question running. And people are already jumping in.
I see a brave soul actually said that they do changes in production. That's nice.
Yeah, let's wrap it up and share the results. Anyone else wants to add their answer? Okay.
Right. Very interesting that it's almost half and half, where a lot of people use one sandbox and other people have one sandbox per developer. Very interesting. And this is something that I'm going to touch on. So thanks, Segi. I'm going to stop sharing the results.
There's also some questions at the chat about it.
Yeah, I think it's like in most, as everything in software development, it depends. That's usually the answer for everything.
Yeah.
So, okay, so thanks for that. So one of the things you should consider again is, should every developer have their own sandbox, or should you work on shared sandboxes? And I know a lot of people feel very strongly about this. You know, they'll be thinking, how can you say that? That, you know, it's obviously the best practice to have every developer have their own sandbox. But as I said, I'm not here to tell you what you should or shouldn't be doing. There are some scenarios where it makes sense to use a shared sandbox. Maybe you have a lot of complex data and you don't have software to do data seeding. And so the best solution is to use a full sandbox and maybe have 2 or 3 developers sharing that. Maybe there are some projects where you could use a hybrid approach where most developers have their own sandbox, but for certain features that are, again, heavily dependent on data, then you can use a shared sandbox. The point here is that it's a question that you should ask yourself, and you should come up with the answer that better satisfies your needs. Next thing is about what type of sandboxes you're going to be using for different types of testing. Also, how are you going to be populating your sandboxes with fake data? And very importantly, how easily can you refresh your full sandbox, right? Because usually when we refresh the full sandbox, we then need to engage in this very long, tedious process of post-refresh activities where we have to remove email addresses and remove sensitive data. And if we go back to that concept of continuous delivery, of automating everything that can be automated, then I think this is a great place where you should practice some automation and let us, the developers or and admins, work on something more important than these post-refresh activities. So here's a typical sandbox strategy where every developer has their own sandbox, and then there is a sandbox after that called integration or QA sandbox. Sometimes they are the same. And this is similar to that concept we saw earlier of continuous integration, where developers merge their individual changes into a common branch. In this case, it's a common sandbox. And the idea is that changes later go from integration to production. Okay, so the next step is choosing which metadata to track. So at the core of a Salesforce deployment pipeline is having your Salesforce DX project stored in Git. And so you need to decide, what are you going to track? Are you going to track only code-based metadata, like, for example, Apex classes, Lightning Web Components, Visualforce pages? Or are you also going to track non-code-based metadata like workflow rules, flows, profiles, etc.? Also, what about changes that you make directly in production? And again, right, how can I say that this is supposed to be a webinar about CI/CD? How can I say that we make changes directly in production? Well, again, I know some companies that do it because they have maybe super users that are allowed to change certain strategic metadata, such as email templates or custom labels, etc. And again, I'm of the opinion that those companies also deserve to do CI/CD. So the question is, if you're going that route, how are you going to integrate that into your CI/CD pipeline? Is that something that you're going to track at all, maybe retroactively? Or are you happy not having an audit of that, right? I can't answer that, but it's something that you need to consider. Right, so I'm just checking if there are any questions there. Okay, no questions. So also, the more you track in Git, the more knowledge of the Salesforce metadata API you have to have. Some metadata types can be very complex, like flows or profiles, page layouts, and it's very hard to manage them in Git. So you need to consider that when you decide what to track as well. What I recommend is that you ask yourselves which metadata, if version, is going to make your releases and applications better. All right, so the next step is choosing a branching strategy. So the Git branching strategy is closely aligned to your sandbox strategy. So it's all about choosing how you're going to organize your Git branches. So things that you should consider is, should you create one branch per Salesforce org? So we saw earlier on the sandbox strategy that we had the integration sandbox, UAT sandbox, and then production. Some people will have one branch per environment. So one integration branch, one UAT branch, and one production branch. Other people have just one branch and they practice a version of trunk-based development where all the changes are merged into a common branch. And then you use that branch to deploy to all your different environments. Again, no right or wrong answer, something that you need to consider. Also, if you're going to use branches, then you need to think, how do we deploy to production? Are we doing Git-based deployments? And if so, from which branch and when? My recommendation is, again, try to have a strategy that aims to have short-lived branches. We saw that one of the reasons continuous integration came to exist was because of the problem of merging long-lived branches. So I would recommend that you aim for something to live short. Right. Okay, somebody asked if I can repeat point number 2. If they're talking about the trunk-based development, I meant that you could have just one branch. Because so some people think, and it's a valid opinion, that your sandboxes are already kind of branches, right? So you have your integration branch, UAT branch, sorry, integration sandbox, UAT sandbox, and then production. And that is already kind of like a built-in branch in the way Salesforce works. So I know some people only use one branch in Git and they merge all the changes into that branch, and then they use that branch to deploy to all environments. So you're essentially deploying the exact same metadata to all the different environments by having only one branch. All right, so let's move on. So here's a sample branching strategy. This is called Gitflow, and it's the one that I'm going to be demoing today. So it's very simple. Basically, you have a main branch that represents your production environment. At the beginning of a sprint, you create a development branch, and then developers create feature branches off of the development branch. When you're ready at the end of the sprint, you merge development into main, and that triggers a production deployment. All right, so let's talk about choosing a CI server.
Hey, Pablo, we also had one question in the Q&A. If you would like
sorry.
to get this one quickly.
Yeah, let me see. What should be considered source of truth, branch or sandbox? That's a tricky question because, and that's probably going to be a long debate. Sometimes I think, for example, the source of truth of what? Of everything that's in the org? Sometimes it's hard for a branch to represent that because there's, as I said, there's metadata that you may decide not to track, right? If you don't want to track something like, again, profiles or flows or something like that, then it's not really the source of truth. So it could be the source of truth of what you decide to track. And again, in Salesforce, we have this very strange mechanism where you can log into the sandbox, make changes, and that has no reflection on your Git branch. Whereas in real, or not real, but traditional software development, usually you do Git-based deployments all the time. So it's almost impossible to make a change directly on a server that doesn't exist in Git. So I would recommend, obviously, that you try to make your branch the source of truth. But again, that's just my opinion. And as I said, it's the source of truth of what? The entire org? Maybe not. Maybe just the source of truth for code-based metadata if you decide to only track those changes. There are also some good comments there on the chat. People think that the branch should be the source of truth, which is what I said. Rob thinks that it should be production. And yeah, as I said, there are different opinions on this. And I think in the end, it's just the nature of Salesforce, the fact that you can log into production and make a change there makes all these arguments a little bit weaker than if we were in traditional software development. There's a question there, does the source of truth is not the master repository? It's the same thing we're discussing. It could be the source of truth, but again, your production environment in the end is what is actually being used by your users. Okay, so I'm going to move on and I'll come back to questions if there are more. So choosing a CI server. So when I was learning CI/CD, this part was actually super confusing to me because I really couldn't understand what a CI server does. And CI here, again, stands for continuous integration. So a simple way to explain it is when you're using Salesforce DX on your computer, you're running commands. You're literally typing commands on your keyboard, right? You're saying SFDX, push, pull, deploy, retrieve, etc. Now, imagine if you wanted to automate some of those commands to run later in the day or on demand. How would you do that? Does that mean that your computer needs to be on 24/7 for that automation to run? Or does that mean that you have to get some other computer and make sure that it's on all the time? That really doesn't make sense, right? So that's what a CI server actually can do for you. One of the many things that it can do for you. So the CI server can create a virtual machine on demand. And this virtual machine can check out your SFDX project, load it into its local file system. It can then respond to events in your version control repository, such as push, pull requests, creation of feature branches, etc. And then in response to those events, it can execute commands on a remote terminal somewhere in the cloud. And those commands will be the same commands that you are used to running locally, such as SFDX commands, maybe bash commands, Node.js scripts, etc. So this is really what a CI server is, and we'll see one in action later. So here are some of the typical CI servers. Today, I'm going to be demoing GitHub Actions. And so the next step is deciding what to automate and when. And I would argue this is the most important part of the webinar. So if you're thinking of something else, I would encourage you to go back and pay attention to at least these 2 slides. So at the core of the Salesforce deployment pipeline is figuring out what you want to automate. And when you start this journey, you may not even know how you're going to automate it or when. And I think that's okay. It doesn't matter. Just figure out, have a conversation with your team. What is it that we would like to automate? So let's say that I decide to automate deployments, and I want to automate the deployment of metadata to the next organization or the next org in the pipeline. I don't know how I'm going to do it or when this automation is going to run. I just know that we don't want to do this manually. Next, let's say that I also want to allow the developer to specify which tests they want to run, if they want to run all tests or only certain tests, and I want this to be as automated as possible. Let's say I also want to scan the code for any vulnerabilities or any readability issues. And finally, I also want to figure out the delta, which means I only want to deploy that which has changed. So rather than deploying the entire branch over to a Salesforce org, I'm going to deploy only the things that have changed. And so these are the things that I want to automate. I don't know exactly how or when, but this is what I've decided with my team that we don't want to be doing manually. The next step is to map those actions that you've decided to automate against events on your version control repository. And this actually becomes your Salesforce deployment pipeline. So let's say that when a pull request is open against the development branch, I want to figure out which metadata has changed. I want to run PMD or static code analysis. I want to do a check calling deployment of the delta to the integration sandbox. And I also want to run the tests specified by the developer. If you see, these are the same actions that I decided earlier that I wanted to automate. The difference is now I'm mapping them against an event in my version control repository. So then I can do the same with other events. For example, when the pull request is merged and approved, then I want to do a full deployment to UAT, run all tests. And when the development branch is finally merged into master, I want to do a full deployment and run all tests as well. And so here, what you see finally is your kind of the matrix for your deployment pipeline. So I'm just going to go over to the Q&A here to see if there are any questions. So there's a question says, so does the CI server actually create a virtual Salesforce environment and load it with metadata and do the testing? No. So the CI server, what it does is, and again, you'll see it in action in a moment because there is a demo, is you'll see it'll download or it'll check out your Salesforce DX project because your Salesforce DX project is stored in version control. So it'll actually check that out into its local file system. And because it's an SFDX project, it can run commands against it, just as if you were doing it on your computer, but it doesn't create a Salesforce environment. Then there's a question there about what are my thoughts on tools like CodeScan and Get Clayton. Is that worth it, or is it better to use PMD? Honestly, I don't have a strong opinion on that. I haven't tried any of these two products. For this demo, I'm going to be using PMD, and it works pretty well for me. Or the Salesforce DX scanner is actually what I'm going to be using. I think these tools have other sort of integrations with maybe Jira or GitHub that may not be easy to replicate out of the box. So I don't really have a strong opinion on that. And there's also a question that says that Salesforce has their own DevOps Center tool, which is still in beta, and it integrates with GitHub. So yes, we saw a demo of that. And Sagi, you remember that demo we saw at Dreamforce? It's still pretty raw, the Salesforce DevOps Center. It looks good, and it's definitely going in the right direction, much better than Chainsets, but it's still pretty raw. I can tell you more about later based on a demo that we saw. It was very funny. Okay, and there's a question about which tool can I use to automate Delta deployments. I'll answer that later because we'll see it. Okay, so finally, enough talking, and let's see a demo. So I have two demos. One is, how to set it up. And then the other one is how to actually use it, right? If you're a developer, how would you use it? So I have a bit of recording and a bit of live, just because some things will take a long time, and I'm not going to do a live demo of CI/CD because it's definitely bound for failure. Okay, so when it comes to the setup, the first part is creating your SFDX project and choosing which metadata you want to track. So here I have my SFDX project with a package manifest file. And what I'm going to do now is I'm going to authenticate to my developer org. Okay, so once I'm done this, I'm going to use this Visual Studio Code extension, which is really good, called Package XML Generator, and it's going to scan my Salesforce org that I've connected to, and it's going to allow me to choose which metadata I want to track in that package XML. And so this goes back to that principle that we spoke earlier about making a conscious decision about what you actually want to track. In this case, I decided to just go with the default. So now I'm just going to right click and click Retrieve Source in Manifest. And this is going to then download all the metadata to my local file system. So if I open the directory here, I can now see all the Apex classes. So now the next step is to upload the SFDX project to GitHub. Very important, we're uploading the entire project, it's not just the metadata, and this is what allows the CI server later to run commands against it. So I'm going to create very quickly here a GitHub repository, and I'm just going to copy the instructions here. I'm going to go back to my local repository, put the instructions in, and then if I refresh, just like that, I have the entire SFDX project in version control. Super simple. The next step is to store the SFDX authorization URLs as environment variables. So I'm going to use this command force or display to get the authorization URL for this sandbox. I could do the same for UAT integration and production. So basically, I'm going to copy that and I'm going to go to my CI server, in this case, GitHub, and I'm going to add this as a secret. If you're using something else, it could be called environment variable or environment secret. And again, this is just what allows the CI server to authenticate to that Salesforce org to automate deployments later. And then I'm going to stop here because I'm going to demo this part live. So once you've done that, the next step is to actually create the pipeline. So typically this is done by writing a gigantic YAML file. So I have this sample YAML file. I'm going to make it a little bit bigger there on the screen. So this is the GitHub Actions sort of format for defining a pipeline. There's a bit of a learning curve because you do need to learn, how to use different types of commands for saying when a workflow should run. But essentially here is where you start running those commands on a remote terminal. So for example, I'm installing Git Delta. I'm installing the SFDX scanner here. And then later on is where I can actually finally do those commands like sfdx source, deploy, etc. So it actually takes a while to learn this. And so I thought this could definitely be done better. So for this presentation, I created a new free and open source tool called Naki, which stands for Not Another CI Tool. You can find that at ci.salto.io. So basically what this allows you to do is to create the entire YAML file that I just showed you in 5 minutes with just a few clicks. And it's going to walk you through the same process that we went through earlier on how we think about our Salesforce deployment pipeline. So I'm going to show it here live. And oops, let me refresh it because I was doing it earlier. So basically you choose your CI provider. In this case, right now, we only support GitHub Actions. There's more coming soon. And let's say I'm going to call this deployment to UAT. Then I'm going to be asked, how am I going to authenticate to my Salesforce org? Am I going to use the SFDX URL or JSON Web Token Flow? In this case, I'm going to use the SFDX URL. Then it's going to ask me what is the name of the secret where that URL is stored in my repository. So let's say SFDX UAT. And then finally, here are the details of the pipeline. So what am I automating? So let's say I want to automate a validation deployment, and I want to automate either deploy the entire branch or just deploy the Delta, the files that have changed. So I'm going to deploy the Delta. Then I need to think, when do I want this to happen, right? And that's the same kind of mapping that we did earlier. Well, I want this to happen when a pull request is open against the development branch. And let's say you could also do main, you could do more with commas. And then I also want to allow the developer to specify which test they want to run directly in the pull request, which I will show how I do it later. And then I want to do some PMD. So I want to scan the code for best practices and security. And then I click on create pipeline, and boom, just like that, you have the entire file generated for you. You don't even need to think about it. Then you can just click on it. It gets copied for you. And then you just go to your project and just drop it in there. So again, that is in ci.salto.io. It's 100% free and open source. And right now it only supports GitHub Actions, but I plan to enable support for Bitbucket and GitLab. I'm just gonna see if there are any questions. Okay, no questions right now. Let's see the Q&A. Why not use Docker image? Yeah, I will eventually use a Docker image for this in the future. Okay, so let me go back to then the other demo. So that was how you set it up, right? So now you have your pipeline set up. You have your repository. So how do you actually use it? How do developers use this on their day-to-day? I have another demo here, which I will walk you through. So at the beginning of the sprint, you have your main branch, right? And then someone's going to create a development branch at the very beginning of the sprint. Once that branch is created, every developer has to go to their Visual Studio Code and do a git fetch, which is going to download that branch for them. And then the next step is to create a feature branch against that branch. So I'm going to create a new feature called, something here. And as the source, I'm going to choose that development branch that was just created in the remote repository. Then I can finally start doing my development. So I'm going to, write some code, and I'm going to deploy to my own sandbox. So we're not doing any CI/CD here. It's just deploying to your personal sandbox, kind of local development. Then we're going to create a test. We're going to run that test to see if everything is working successfully. And I wish Salesforce development was this simple, as I'm showing in the demo. But once we have everything and we're happy, then the next step is to add or commit this to Git. And then we're going to push this feature branch over to the remote repository. So I'm going to do a git push. I need to use the correct command there. So I'm going to copy paste that. And this is going to push that branch and that commit to the remote repository. So if I click on that now, what I can do is now I can create a pull request from the feature branch against the development branch. Now I can include a description here of the changes I made. And I want to only run one test. I want to run this Dreamforce class test. So what I'm going to do is I'm going to add it in the pull request in this special syntax that I have. And don't worry, I'll show exactly how I made this. But basically, I specify that I just want to run that test. If I scroll down here, I can see all the changes that I've made. And if I'm happy, I can click on create pull request. So once that's done, this is where the first workflow starts, right? So now the first automation is kicking in, and this is the CI server essentially booting this virtual machine, downloading all the dependencies like the SFDX, CLI, the scanner, all these things that you normally have on your computer, but it's being done for you in a remote machine somewhere on the internet. And then it's going to do a validation deployment against the integration sandbox. So if I go back to my sandbox here, we'll see that there is a validation that just succeeded. If I open the details, I'll see that there's only 2 tests that run, and those are the 2 test methods from that class. I can expand this here and see the output, and that confirms that only 1 Apex class was run. Okay, so great. So we have a successful validation against the next sandbox in the pipeline, the integration sandbox. Another thing that we wanted to do was PMD, right? We wanted to scan the code for some vulnerabilities. So I have this directly in GitHub. So if I go over to details, I can then see what are the alerts. So in this case, the Salesforce DX scanner is telling me that I am missing a third parameter on the system.assert method, right? And this is great because you can see it directly in the GitHub UI. You don't need to use any third-party tool for this. And this is included in the NACI file that I showed you earlier. So let's say that I decide that it's not a big deal. I'm not going to fix that because it doesn't really matter. So then I'm happy with this change, and I'm going to squash and merge, which is going to merge this branch into the development branch. So this is kind of the developer workflow. Every developer would be doing this flow. Now that the development branch has had something pushed onto it, there's the second workflow kicking in, right? So now we're going to deploy the entire branch over to the UAT environment. And so if we go back to our UAT, we'll see that now there's going to be a successful deployment. It will also deploy to the integration sandbox as well. And we can see that here all the tests were run because that's what I specified in my YAML file. The next step is that at the end of the sprint, hopefully all the changes that you're happy with would be in the development branch. And so the next step, if you want to push that or deploy that to production, is to create a pull request from the development branch to the main or master branch. So let's go ahead and do that. And then I can modify that description here to include, sprint 1, 2, 3 and some details. I can scroll down and I can see all the different commits, which again, if this was a real team, you would see 1 commit per user story. So you have a good audit there of what has changed. And let's say that we all decide that we're happy with these changes. We're happy to deploy this to production. So the final step is to do a squash and merge to deploy this to production. And then here is the same thing. There's another automation that is listening for events on the main branch. When a push is made on main or master, is going to run another workflow. And in this case, it's just a deployment of the entire branch to the production org. So if we go back to our production, we'll see a very nice green and quick deployment. Now, the final thing that I decided to automate was the creation of a GitHub release. So if I go back to GitHub here, we'll see that there's a release here with the date. So I think this is really nice for kind of like an audit of your releases. So you have the date, you also have a list with all the commits, which again, in the real world would be user stories. And you also have a snapshot of what the code looked like at that point in time, which you can use for troubleshooting something, or maybe as a rollback to a previously known good version of your Salesforce org. So I need a break. So let me drink some water and see what are the questions there.
Yeah, we had a few people throwing out some questions in the Q&A. So
Right.
that's
So
it.
yeah, so Nicholas is asking why allowing people to select their test classes while they can potentially break any one of them. Again, so this is where it's an opinion, and I think it depends. There is no right or wrong answer on whether you should always run all tests. I'll give you my experience. I used to work in a very large Salesforce implementation. And so, for example, sometimes we would be doing changes for a service cloud, sorry, for a Lightning Web Component Apex controller that lived on the customer community. Very specific, very narrow sort of user story. Make this change here. And then we had to run all tests, and we run tests that are related to CPQ and financial force, something completely unrelated in a completely different part of the code base. And, those guys were doing something else, and those tests were failing, and it blocked our deployment. So my experience is like, why should I run tests for CPQ and financial force when I'm doing something very, very specific, for something that is going to be in the customer community, and that it's a Lightning Web Component controller that is never going to be called by Apex or anything else. So my opinion is that you should have that flexibility. I'm not saying that you shouldn't run all tests, but I think it's nice that you have that flexibility. And I think Salesforce agrees with me, because otherwise the specified test flag wouldn't exist. There's a question there about the lifetime of the development branch. Do we create a new development branch every 2 sprint? Yes, normally that's what you do. You delete the once you merge the development branch into the main branch, you can delete it, and then you can create a new one at the beginning of the sprint. And then it says, does GitLab and other CS servers support events on pull requests to trigger a pipeline? They definitely do. Yeah. There's a question about how that particular test class picked up from the comment section. I will show you that. Don't worry. I know people are anxious to see how I'm passing that name on the pull request to the actual Salesforce CLI. There's a question about automating merging code. Can you automate merging code deployed to production into existing branches? Right. So I think the question here is about, if you make a deployment to production, how do you make sure that that change is retroactively applied to any other sandbox in the pipeline? Maybe even the developer sandboxes that are not necessarily part of that pipeline. You could have another automation there. You can have another CI workflow that takes the exact same deployment and then just pushes it onto the developers. Now that could override something that they're working on. So I know in GitHub Actions, you can also trigger workflows manually. So you could create a manual workflow that the developers themselves can trigger to sort of rebase their sandbox with the latest stuff that is in production. Okay, so I'm going to stop here with the questions for a moment, and I'm going to go back to the slides, and I'll go back in a moment with the questions. Okay, so that was for the demo. So how I did a few things. So here's how I authenticated to the target org. Again, I use the SFDX authorization URL. You could have also used the JSON Web Token, but that requires a connected app in each sandbox, and I find that to be super annoying. So I think this works very well. Now, how did I pass the Apex tests from the pull request into the Salesforce CLI? So I basically made up the syntax, Apex : and then brackets and the name of a class. You can specify multiple classes separated by a comma, or you can also put the word all, and all means all classes. What I have is, in the pipeline, I have a little bit of bash that basically reads the pull request body, and it then puts those contents into a text file, and then it runs a Node.js script. The Node.js script is then going to read the contents of that text file, which is, again, the contents of the pull request, and then is going to go over line by line. And if it finds that limiter, it's going to then extract those test classes there, and it's going to put those classes in another environment variable. And then when I call the Salesforce CLI for deployment, I pass that environment variable as the test classes that I want to run. So how did I generate the Delta deployment? This is a question that came up earlier. So I'm using this SFDX plugin called SFDX Get Delta, which is really good. I highly recommend it. It's super easy to use. And that's kind of the command that I'm running on my pipeline, where I say, okay, the source is the Force app directory, and I want the output of this to be the chain sources, which is going to be just that Delta. Now, there's a good argument that sometimes you reach a certain point where this kind of automation that I showed hits a limit, right? So we've done a lot of really good stuff. We were able to do Delta deployments, pull requests, automated PMD analysis and stuff like that. Sometimes you do hit a limit and you need something a bit more robust like Salto. So I'll just give a few examples of that, and then we'll go back to other generic CI/CD stuff. For example, if you want to do CI/CD for configuration data like CPQ, if you think about it, if anyone here is familiar with CPQ data, it's actually data that should have been metadata. It's only data because it's a managed package. But if CPQ had been an original Salesforce feature, all the pricing rules and all that stuff would have been under the setup menu. But because it's a managed package, then it's actual data. And so what that means is you can't include this in your CI/CD pipeline. So with Salto, you can, because we can translate your data into metadata. So what I'm showing you here is a screenshot of a pull request from a feature branch into main, where we are changing a value of a CPQ price condition. Also, I know that a lot of people are hesitant to do CI/CD because of, again, very complex metadata types like profiles, flows. Flows now are, super popular. They're sometimes really big, and looking at the diff in XML is really, really hard. So in Salto, we actually have our own sort of diff visualization, which looks a lot nicer. It basically looks like a Google Doc with changes. So you can see exactly what has changed, and this works for all the complex metadata types. Then sometimes it's really hard for admins and developers to collaborate together. So in Salto, the way we do CI/CD is we give you a CLI. You can use GitHub Actions, Bitbucket pipelines, whatever you want, just the same way that I showed. But those pull requests are going to show up on the Salto UI, and then admins can collaborate on those as well. Finally, we also know of a lot of errors that can happen. And so we scan your metadata and sort of alert you if there's something wrong before you actually deploy. All right, so finally, we went through all that stuff, right? And I did say that this was about design patterns. Having gone through all that, after I prepared for this presentation, I realized that some patterns sort of emerge, right? Some kind of reusable decisions that you can make on how to configure your Salesforce deployment pipeline. So these are the patterns. It's actually the same thing we saw earlier. If for your sandbox strategy, your patterns or your choices are using a shared sandbox, everyone has their own sandbox, or a hybrid approach. For source control, you can track all metadata in Git, or you can track only code-based metadata along with a few other things. For your branching strategy, you can use one of the common branching strategies like Gitflow, or maybe one branch per org, or you can use a single branch and try to practice what is known as strong-based development. For deployments, as you can see, we have full deployments, or now with SFDX Git Delta, we can also practice Delta deployments. Then for a CI server, your options are either use a built-in CI server. And what I mean by that, and I did not explain this well earlier, is GitHub Actions comes with GitHub, right? So if you have GitHub, then you have GitHub Actions. It's the same software. The same is true with Bitbucket pipelines, comes with Bitbucket. There are other CI servers like Circle CI or Jenkins that are actually like an external server. And so you need to decide what makes sense for you. Use an integrated one if you can, or use an external one. When it comes to running tests, you can either run all tests or run specific tests. I know I see in the comments that that's a point of debate here, but again, it's a choice that Salesforce has given us. So I think we should use it when it makes sense. For your deployment pipeline triggers, you have different options. And obviously I didn't fix the slide because this should have been push, not PSU. But your options are when the branch is created, trigger automation when a pull request is created, when a pull request is closed, or when something is pushed onto a branch. And then for a CI/CD solution, you can either go custom, the way I showed, where you can do everything yourself, or if you hit a limit, then you can use a third-party platform like Salto. Finally, I want to thank you for being here, and I would like to encourage you to follow me on LinkedIn. I have started a CI/CD weekly thing where I every a few days a week I put tips about CI/CD for Salesforce. So if you want sort of a refresher on this session, I would encourage you to follow me or just follow the CI/CD weekly tag for weekly tips on CI/CD. So thank you very much. Now we can go and check out some questions. Okay.
So we have a few. I'm not sure if we'll be able to answer all of them before we need to wrap it up. So maybe pick 2 or 3.
Oh, yeah, it's a long time. Okay, so let's see. Let's see. So there's a question here: for 2 main sandboxes and 1 production, while having up to 10 production deployments per day, what branching strategy would you recommend? If you have that many deployments a day, I wouldn't recommend the Git branching strategy that I showed, because then you would have to be, you don't really have the sprints, right? So when would you recreate or delete that development branch? You could look into trunk-based development. Again, it sounds like you're already doing something very good if you can do 10 deployments a day. So I would highly encourage you to look into trunk-based development. It's definitely something that can help you. There's a question here: why not create test suites per product feature and then execute along deployment? I don't know that you can run a test suite on the Salesforce CLI. If you can, let me know on the comments, but I don't know if that's possible. Then yeah, that would have been a better option. And then there's a question: is there going to be a recording? Yeah, it's going to be recorded, and you can share it with your colleagues as well. So thank you, guys. Thank you very much for joining. Highly appreciate it. I hope you enjoyed it and you learned something. Thank you.
Thanks, Pablo.
Okay.
Bye, everyone. Have a good one.
Okay. Bye-bye.